Today we're going to learn how to solve a system of three equations with three variables by using elimination. All right, here's the process. There's 3 steps to it, basically. Step 1 says pair 2 equations to eliminate a single variable. Next, pair the equation that was not used with one of the equations that you already used to eliminate the same variable as before. Step 2, write the 2 new equations as a system of 2 equations and 2 variables and solve. Step 3, substitute the 2 values that you found back into one of the original equations to find the third variable. So let's look at an example here. Here's a system of 3 equations with 3 variables. The solution is a point that has an x, y, and z coordinate. So I'm going to pull this little template up here that I like to use to help me go through the steps to solving this. Okay? So step 1 says use elimination to make a system of 2 equations and 2 variables. Both of your 2 new equations should have the same 2 variables. So what I like to do is I like to label these 1, 2, and 3. I'm going to look at these 3 equations. I'm going to look at the x's, I'm going to look at the y's, I'm going to look at the z's. I'm going to try to decide what variable would be the easiest to eliminate from all 3 of them. So we want opposites. Well, on the x's, we don't have opposites. We got 2, 3, and 1 are the coefficients. On the y's, we got 1, -1, and -1. So we have some opposites there. So it looks like the y's are going to be the easiest. Well, let's check the z's. Z's, we got -1, 2, and -1. So the easiest variable to eliminate would be the y's. Okay? So what I'm going to do is I'm going to take equation 1 and add it to equation 2. So if I take equation 1 and add it to equation 2, I get 5x plus z is equal to 4. Okay? So I use equation 1 and 2. I haven't used equation 3 yet. So that means I have to use equation 3. And I want to eliminate the y in equation 3. So what could I add to equation 3? I could add equation 1 to it. Okay? So let's take equation 3 and add it to equation 1. We get 3x, the y's cancel out, minus 2z equals 5. Okay? So now, these 2 new equations that we have, let's call these equations 4 and 5. Okay? You should know how to solve this. What we got it down to is a system of 2 equations with 2 variables. So I'm just going to write it down here in this box. 5x plus z equals 4. 3x minus 2z equals 5. These are my 2 new equations, 4 and 5. I want to solve this system. So we want to solve this system of 2 equations with 2 variables. You can solve it by elimination or substitution, however you think is going to be easiest. To me, it looks like it would be easy to eliminate the z's. So let's multiply this one here by 2. So if I multiply that top equation by 2, I get 10x plus 2z equals 8. The bottom equation, I'm just going to keep it the same. I'm just going to rewrite it over here. 3x minus 2z equals 5. Let's add these together and see what we get. So we get 13x, these cancel out, is equal to 13. So divide both sides by 13, we get x equals 1. Now we know what x is. So now we need to find what z is. So let's take x equals 1 and plug it back into one of these. Plug it back into equation 4 or 5. It doesn't matter which one you use. I'm going to plug it into equation 4. I'm going to plug it into the top one. I'm going to plug x equals 1 into this equation so I can find what z is. So when I do that, I'm going to have 5 times 1 plus z is equal to 4. So we have 5 plus z equals 4. Minus 5, z equals -1. Okay, so now we're on step 3. Step 3 says take the two new values that you found and plug them back into one of the original equations. So it doesn't matter which one we use. Let's see which one I want to use here. Let's use equation 3. Equation 3 is x minus y minus z equals 0. We know what x is. X is 1. So substitute 1 in for x. We are looking for y, so leave y alone. And z is -1. So we got minus -1 here. When we have minus and -1, remember that becomes plus 1. So if you simplify the left-hand side, we got 1 plus 1, which is 2. So we have 2 minus y equals 0. Minus 2, we get negative y equals -2 divided by -1. So y is 2. And then the last step is to write your solution as a point. Okay? So my solution to this system, when we write it as a point, we always put the letters in alphabetical order. That's going to be x, y, z. So the solution to this system is the point 1, 2, -1. Okay? This isn't three-dimensional space. It's 3D. That's why it has 3 dimensions. We're not going to try to graph these. These are difficult to graph. Okay? But if I were to graph these, they wouldn't be lines, they would be planes. And where the planes intersect would be this point right here, 1, 2, -1. All right, I'm going to try one more example here. All right, here is my example. Let me get that template and drag it over there to help me go through the steps here. So let's label our equations 1, 2, and 3. We'll call this equation 1, equation 2, equation 3. Look at the equations. Try to decide what variable looks the easiest to eliminate from all 3 of them. X's, we got 2, 1, 15. That's not going to be easy to do. Y's, we got 1, 4, and 6. Again, that's not going to be easy to do. But on the Z's, we got -1, 2, and -2. These two already have opposites. And then all we would have to do is multiply this one by 2. So it's going to be the Z's that we're going to eliminate. So let's do the easy one first. So let's take equation 2, add it to equation 3. What that's going to do, that's going to give me my new equation that I'm going to call equation 4. So equation 2 plus equation 3. That will give me 16x plus 10y equals 28. The z's canceled out. So now, let's take a look at what we have done so far. We used equation 2 and 3. We haven't used equation 1. So now I have to use equation 1. And I need to eliminate the same variable. So we eliminated the variable z. So I'm going to get rid of the z here in equation 1. Well, I'm going to have to combine that with either equation 2 or 3. Well, the z up here is negative 1z. If I combine it with equation 2, let's use equation 1 and 2. If I just added them together, the z's won't cancel out. So what I'm going to have to do is I'm going to have to multiply equation 1 by 2. So if I do that, I get 4x plus 2y minus 2z equals 10. So this is equation 1 multiplied by 2. Well, I'm just going to keep equation 2 the same. I'm just going to write it under it. So I got x plus 4y plus 2z equals 16. And I'm going to add these together. So here's what I did. I took equation 1, times it by 2, and I'm adding equation 2 to it. That's going to give me my new equation, 5. So what do we get? We got 5x plus 6y equals 26. So now, let's take our equation 4 and 5 and write it as a system of two variables. I want to solve this system. I want to solve for x and y here. I can do elimination, I can do substitution, okay? Whatever we want. Well, substitution is not going to be a good choice, so let's do elimination. Let's eliminate the y value. So let's think about what we're going to have to multiply both equations by to get rid of the y. Well, we can multiply the top equation by 6. Let's multiply this top equation by 6 and rewrite it. So we're going to take 16 times 6 is 96. 6 times 10 is 60y. And then 6 times 28 is 168. What am I going to have to multiply the bottom equation by? Well, we're going to have to multiply by negative 10. So what we end up with is negative 50x minus 60y equals negative 260. All right, let's add these together. (96x minus 50x) is 46x. These cancel each other out. 168 minus 260 is negative 92. So divide both sides by 46. And we end up with x equals negative 2. Okay, now we got to find what y is. We know x is negative 2. Now let's find out what y is. So let's substitute negative 2 into this equation. So plug negative 2 in for x. So we have 5 times negative 2 is negative 10. Plus 6y equals 26. Add 10 to both sides. We get 6y equals 36. Divide by 6, divide by 6. We get y is 6. So we got x is negative 2, y is 6. So now we just got to find what z is. So the final step is to take your two answers that you just found and plug them back into one of the original ones. Let's use the equation 2. So equation 2 is x plus 4y plus 2z equals 16. Let's plug in the values that we found. We found x to be -2. Y is 6. We got -2 plus 24 plus 2z equals 16. So now we have 22 plus 2z equals 16. So let's subtract 22 from both sides. So 16 minus 22 is -6. So we got 2z equals -6. So z is -3. And then last step, I want you to write it as an ordered pair. So the solution to this system is the point -2, 6, -3. That's the solution. I know these are long. They take up a lot of space. I don't want you skipping steps. I want you to show all your work. That's why I only gave you 2 problems to work on. So I want you to work it out on a sheet of paper, take a photo of it, upload it. If you need to take an additional photo for your second problem, do it. You can take as many photos as you want and upload as many photos for this assignment. Just make sure I can read them, make sure they're clear, okay?